ಆಮೇಲೆ ಈಗ ಕರೆಂಟ್ಲಿ ಅವರು ಮುಖ್ಯವಾಗಿ IBM ಸಂಸ್ಥೆಯಲ್ಲಿ ಚಿಪ್ ಪವರ್ನ ಲೀಡ್ ಆಗಿದ್ದಾರೆ. ಹೇಳ್ದಂಗೆ ಸೀನಿಯರ್ ಸರ್ಕ್ಯೂಟ್ ಡಿಸೈನ್ ಇಂಜಿನಿಯರ್ ಮತ್ತೆ ಚಿಪ್ ಪವರ್ ಲೀಡ್. ಹಾಗೇನೆ ಅವರ ಹೆಸರಲ್ಲಿ ಒಂದು ಅಂತಾರಾಷ್ಟ್ರೀಯ ಪೇಟೆಂಟ್ ಇದೆ. ಅವರಿಗೆ ಏನು ಅಂದ್ರೆ ಪೇಟೆಂಟ್ ಬಗ್ಗೆನೂ ಹೇಳಿ ನಮ್ಮ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ಅದು ಗೊತ್ತಾಗುತ್ತೆ. ಪೇಟೆಂಟ್ ಅಂದ್ರೆ ಏನು, ಹೇಗೆ ತಗೊಳ್ಳೋದು, ಅದ್ರ ಲಾಭಗಳೇನು ಅಂತ ಗೊತ್ತಾಗತ್ತೆ. ಹಾಗೇನೆ ಅವರಿಗೆ ಪ್ರಶಸ್ತಿ ಬಂದಿರೋದು ಮೇಜರ್ ಔಟ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಟೆಕ್ನಿಕಲ್ ಅಚೀವ್ಮೆಂಟ್ ಅವಾರ್ಡ್ ಬೈ ದ IBM CEO ಅಂತ. ಅವರು ತಮ್ಮ ಕೆಲಸದ ಜೊತೆಗೆ ಸಂಶೋಧನೆ ಮತ್ತು ಬೇರೆ ಬೇರೆ ಕಡೆ ಈ ಇದ್ರ ಬಗ್ಗೆ ಇವತ್ತಿನ ದಿನ ಏನು ಕೃತಕ ಬುದ್ಧಿಮತ್ತೆ ಅವ್ರು ಮಾತಾಡಿದ್ರು AI, ಅದು ಆಕ್ಚುಯಲ್ ಇಂಟೆಲಿಜೆನ್ಸ್, ಆರ್ಟಿಫಿಷಿಯಲ್ ಇಂಟೆಲಿಜೆನ್ಸ್, ಆಗ್ಮೆಂಟೆಡ್ ಇಂಟೆಲಿಜೆನ್ಸ್ ಎಲ್ಲದ್ರ ಬಗ್ಗೆನೂ ನಿಮಗೆ ತಿಳಿಸ್ಕೊಡ್ತಾರೆ. ಹಾಗೇನೆ ಅವರು ಎಷ್ಟೊಂದು ಸಭೆಗಳಲ್ಲಿ ಕಾನ್ಫರೆನ್ಸ್ಗಳಲ್ಲಿ ಇದ್ರ ಬಗ್ಗೆ ಮಾತಾಡ್ತಾರೆ. ಟ್ಯುಟೋರಿಯಲ್ಸ್ ಕೂಡ ತಗೋತಾ ಇರ್ತಾರೆ ಸ್ಟೂಡೆಂಟ್ಸ್ಗೆ. ಸೊ ಈ ಒಂದು ಅವಕಾಶ ಬರ್ತಿರೋದು ನಿಮಗೆಲ್ಲ ಒಂದು ಸೌಭಾಗ್ಯ. ಈ ಮಾತುಗಳೊಂದಿಗೆ ಕರ್ನಾಟಕ ವಿಜ್ಞಾನ ಮತ್ತು ತಂತ್ರಜ್ಞಾನ ಅಕಾಡೆಮಿಯಿಂದ ಮತ್ತೊಮ್ಮೆ ಧನ್ಯವಾದಗಳನ್ನು ಹೇಳ್ತಾ ಶ್ರೀ ಆದರ್ಶ ಸುಬ್ರಹ್ಮಣ್ಯ ಅವ್ರನ್ನ ಸ್ವಾಗತ ಮಾಡ್ತಾ ನಿಮ್ಮ ಒಂದು ಉಪನ್ಯಾಸ ಕೊಡ್ಬೇಕು ಅಂತ ಕೇಳ್ಕೊತೀನಿ. ಶ್ರೀ ಆದರ್ಶ ಸುಬ್ರಹ್ಮಣ್ಯ.
ಧನ್ಯವಾದಗಳು. ನನ್ನ ವಾಯ್ಸ್ ಸರಿಗೆ ಕೇಳಿಸ್ತಿದ್ಯಾ?
ಕೇಳಿಸ್ತಾ ಇದೆ. ಕನ್ನಡ ಇಂಗ್ಲಿಷ್ ಎಲ್ಲ ಮಿಕ್ಸ್ ಮಾಡಿ ಸರಳವಾಗಿ ಸರಳ ಸಂವಹನ ಇರ್ಬೋದು. ದಯವಿಟ್ಟು ಶ್ರೀ ಆದರ್ಶ ಸುಬ್ರಹ್ಮಣ್ಯ.
ನಾನು ಅದನ್ನೇ ಹೇಳಕ್ ಹೋಗ್ತಿದ್ದೆ. ಇವಾಗ ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಪ್ರೆಸೆಂಟೇಶನ್ ಮೋಸ್ಟ್ಲಿ ಇಂಗ್ಲಿಷ್ ನಲ್ಲಿ ಕವರ್ ಆಗುತ್ತೆ. ಯಾಕಂದ್ರೆ ಮೋಸ್ಟ್ಲಿ ಟೆಕ್ನಾಲಜಿ ರಿಲೇಟೆಡ್ ಟರ್ಮಿನಾಲಜೀಸ್ ಇರೋದ್ರಿಂದ English will be the major language of communication. But before we start on this, Dr. Ayappan requested me to talk a bit about my patent and what that process is and what the value it adds is. So patent ಅನ್ನೋದು ನನ್ನ patent ಇರೋದು ಟ್ರಾನ್ಸಿಸ್ಟರ್ ಟೆಕ್ನಾಲಜಿ ನಲ್ಲಿ. ಟ್ರಾನ್ಸಿಸ್ಟರ್ಸ್ ನಲ್ಲಿ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಕಾನ್ಫಿಗರೇಷನ್ ಮಾಡಿದ್ರೆ when we are implementing any circuit in the form of transistors, essentially you can think of transistors as switches that you will turn on a switch or turn off a switch for current to pass through and do something, do a task. So ಇವಾಗ ಏನಾಗುತ್ತೆ, ಈ ಟ್ರಾನ್ಸಿಸ್ಟರ್ಸ್ ಡಿಸೈನ್ ಮಾಡುವಾಗ ನಾವು ಅದಕ್ಕೆ there will be some constraints that ಇವಾಗ ನಾವು ಸ್ವಿಚ್ ಆನ್ ಮಾಡಿದ್ರೆ ಅದಿಷ್ಟು ಟೈಮ್ ಒಳಗೆ ಹೋಗ್ಬೇಕು ಇನ್ನೊಂದ್ ಕಡೆಗೆ, ಅಥವಾ ಇಷ್ಟ ಟೈಮ್ ಮುಂಚೆ ಹೋಗ್ಬಾರ್ದು ಅಂತಾನು ಒಂದು ಕನ್ಸ್ಟೆಂಟ್ ಇರುತ್ತೆ. ವಿ ಕಾಲ್ ದಟ್ ಲೇಟ್ ಮೋಡ್ ಟೈಮಿಂಗ್ ಅಂಡ್ ಅರ್ಲಿ ಮೋಡ್ ಟೈಮಿಂಗ್ ಇನ್ ಟ್ರಾನ್ಸಿಸ್ಟರ್ ಸರ್ಕ್ಯೂಟ್ ಅಂತ. ಸೊ ಮೈ ಪರ್ಟಿಕ್ಯುಲರ್ ಪೇಟೆಂಟ್ ವಾಸ್ ರಿಲೇಟೆಡ್ ಟು ಡಿಸೈನಿಂಗ್ ಸಮ್ ವೆರಿ ಸ್ಪೆಸಿಫಿಕ್ ಸರ್ಕ್ಯೂಟ್ಸ್ which would provide both late mode benefit and early mode benefit, in the sense that in particular ಇವಾಗ ನಿಮ್ಮ ಮನೆಯಲ್ಲಿ ನೀವು ಸ್ವಿಚ್ ಬೋರ್ಡ್ಸ್ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಡಿಸೈನ್ ನೋಡಿರ್ತೀರ ಅಲ್ವಾ, ಈ ಸ್ವಿಚ್ ಆನ್ ಮಾಡಿದ್ರೆ ಅದು ಆ ಲೈಟ್ ಆನ್ ಆಗುತ್ತೆ ಎಕ್ಸೆಟ್ರಾ ಎಕ್ಸೆಟ್ರಾ. ಸೊ ಅದೇ ತರ ಇಲ್ಲೂ ಅಷ್ಟೇ ಪರ್ಟಿಕ್ಯುಲರ್ ಸರ್ಕ್ಯೂಟ್ಗೆ we had designed it in such a way that it would meet both those constraints with lesser impact compared to what was present at that point. So that ended up being an international patent along with a couple of my esteemed colleagues in IBM. So the value of a patent is that you hold all the rights to that particular idea. Now a patent can be of different gradations. It can be an extremely high value patent, sometimes an extremely high value patent. For example, all of you may be aware of Coca-Cola. The content of Coca-Cola is a patent, but the patent is not released to the public because they want it to be completely confidential, because it's a very high value revenue generating thing for them. So depending on that, there are various levels of patents. So it is of a very high value. It adds a lot of credibility to your CV, as well as it adds a lot of credibility to your industry where you're working. So patents are certainly something all students should think of early in their careers. And even patents are essentially intellectual property anta. So intellectual property doesn't necessarily have to be a patent. You can always go towards public. You'll see that many times what happens is may apply for a patent, but it may go out as a publication also, which is of a very high value as well, where it shows that you are the first one to come up with this idea, and anybody who uses that idea will have to, acknowledge your contributions. So certainly patents are something which I encourage all students to start looking at. To just give you another vague example or another interesting example, um, I'm assuming all of you are aware of Michael Jackson, and there was a particular dance move in one of his dance videos where he stands and bends from the same location completely near the ground, and that was possible because he designed a certain type of shoes, and actually that shoes is a patent now, since then actually. And so there is no limitation to what you can patent. Essentially the idea should be novel, it should not be something which is obvious, and it should add value. Those are the main criteria. So that's just a brief on patents because I was requested about the same. So before I start with the main topic, thank you for this opportunity. I would like to start with uh, this topic is related to intelligence and the application of intelligence, and there is no intelligence without um, our gurus, our parents, and our teachers. So I will start with a Guru Vandana. Um, Om Akhandamandalakaram Vyaptam Yena Characharam Tatpadam Darshitam Yena Tasmai Shri Gurave Namaha. Now this particular one shloka which I used is also going to be relevant in the future slides, and I will touch upon that when I get there. But today we are going to talk essentially about AI in the industry and in common usage. It is known as artificial intelligence, but I have titled this as apt intelligence because it's all about using the right method in the right place for the right use. So it could be usage of our human intelligence, it could be usage of a machine's intelligence, or it could be a hybrid model where you use the machine's intelligence to supplement your own intelligence. And that is what is called augmented intelligence. So I will get to that. But that's why I've just titled this as apt intelligence. It's where you use it and how you use it, which matters the most. And like I mentioned, once one note of thanks to my parents and my gurus and teachers, one of whom is actually Dr. Ayappan as well, from whom I've learned a lot just by observing him. But the main lessons is that no matter how much you learn, your humility matters the most, and he's an embodiment of it. So thank you for that. Moving on. Okay, so this is today's agenda. ಏನೇನ್ ಕವರ್ ಆಗತ್ತೆ ಅಂತ ಇಲ್ಲಿ ತೋರಿಸಿದೆ. First, let's talk about intelligence. There's a lot of usage of the word, but do we really understand what it means to be intelligent, or what is intelligence? Then we'll touch upon the cornerstone or the main stone of any kind of intelligence, because humans are the most intelligent beings on this planet. And all of the forthcoming slides, or rather work which artificial intelligence or augmented intelligence deals with, is actually based on how humans manifest their intelligence. So everything which you see related to artificial intelligence is actually an extension of human intelligence. So that's very important to know, because we need to set that base as to how humans learn, how humans establish their intelligence. And then we'll get into artificial intelligence, what it is and why it is required, some brief history on how it evolved over the years, and the challenges faced. Then we'll get into what are the types of artificial intelligence which are present at this point. Then we'll get into some topics about machine learning and deep learning, which people may have heard about, and then some challenges which currently exist with artificial intelligence. Then we briefly touch upon another common term, which is augmented intelligence. We do have to note that artificial intelligence and augmented intelligence are not necessarily the same, but it's part of it. And then I'll briefly touch upon prospects, the exciting world of prospects which exists in this area. And we have to note that this is something which will touch simply every aspect of humankind. It may may go from physics analysis to agriculture to market analysis, finance, or even chip design for that matter. You will see that artificial intelligence is a concept which we can um, use anywhere, just like we use human intelligence everywhere. This is going to be used everywhere in the near future, and it is very imperative for young students like yourself, whoever is attending this or seeing this later, to get yourself acquainted early with these concepts, so that you can be, better prepared for the future. Okay, so let's briefly touch upon what is intelligence, and essentially it's all about how we perceive information and how we retain it in memory and then use it depending on what is the context in a very adaptive manner. We don't use it as is, we will use it in an adaptive manner based on what the situation is. That is essentially what we would call intelligence, because it's very dependent on the context, it's very dependent on all the prior information which you have based on either your experiences or your knowledge sources, or even your reading habits or whatever, right? So it's all about exercising that in the best way possible for the required intended result. So that is what you would refer to as intelligence. And this is a bit academic, but it's still worth knowing that what are the types of intelligence. And that cartoon there kind of shows some of the uh, a pictorial way of understanding what exactly is the difference between the various things which we use. So ಇವಾಗಲ್ಲಿ ಇಲ್ಲಿ ಇನ್ನೊಂದಿದೆ, if you have just raw data, if you are given just uh, n number of data, you don't know what that data is. In the first step, or what you would call knowledge would be how you would classify the data. Like for example, in this first picture, you see green dots and purple dots. So that's essentially you've taken in the data and you've classified that into some different components. And then experience will be about how can I connect these dots in a certain manner to get a certain result. And then intelligence will be the next step, where you can foresee that if I connect this in this particular fashion, then I can get another beautiful result or useful result. So that's what intelligence is in a nutshell. And we, like I said, the first one would be human, and in human there are various types. This is important to know because this is also something which we will apply in AI. So there is academic intelligence, then there is experiential intelligence, then there is emotional and social intelligence, which is more human specific at this point, at least with the current level of development. But these are all important to know because these are all part of intelligence, especially when we are living in a human world where we are dealing with humans. Emotional and social intelligence also become very important components apart from just the theoretical and experiential knowledge. Then we also have non-human intelligence. To take some specific examples, there is so much which we have learned from animals and insects. If you've seen some of our helicopters or some of the advanced defense things, a lot of those developments are based on non-human intelligence observations. Like how do insects work? How do they flutter their wings in a certain way with the smallest form factor so that we can develop a better defense application or whatnot. So those are also key to note that learning can be from anywhere, and you have to be open to make sure that you learn from anywhere. Now I started this talk with that shloka, and akhanda mandalakaram. So everywhere, whether it's walking or whether it's moving or not moving, there can be something that can be learned. And that's what applies here for intelligence. You should be open to learning from any place so that you can use that to aid some better or higher function later. So now, based on both of these human and non-human intelligences, there is artificial intelligence, which is essentially training machines to do something which humans can do, especially for repeatable tasks. And it starts with repeatable tasks, but it extends to many different things. And That is what we'll talk about a bit more in detail today. Okay. Um, Moving forward, now human intelligence is the most complex form of intelligence at this moment. Um, like the chart on the right shows, there are so many aspects to it. There is naturalistic, there is mathematical, visual, musical, interpersonal, intrapersonal, kinesthetic, and linguistic forms of intelligence in humans. And each of them, if you notice, deals with a different um, input, so to say. For example, all our inputs are our sense organs and our previous experiences and our learnings. So just like that, any system which has to be intelligent has to um, build on a platform which has been experienced to earlier. So just kidding. Was there a question on chat? Um, so yeah, so we build on the experiences which we've had earlier, and they are essentially formats of data which we have assimilated to build a knowledge base and to take certain decisions. So it's very important to understand what is the difference between intelligence and learning. Now, learning is a part of intelligence. So intelligence is essentially cognitive, where you're learning from various sources. You're putting them together in various ways and forms to make a certain concept. You're understanding it and then reasoning it out and applying it in certain ways to form a decision. So intelligence is that whole process, whereas learning is all about assimilating that information, retaining it, and then recalling it for future purposes. So this is important. I'm calling this out specifically because this is something which we are going to see as a major thing when we are going to talk about artificial intelligence, because learning in itself does not constitute everything. And the cognitive portion of the system or the artificial intelligence is very important as well. So it's important for us to understand the difference here. And so the the human brain forms a major inspiration for all of the works which are related to artificial intelligence, and it's a wonderful system. Essentially, if you think about it and correlate it to um, a personal computer or a laptop which you may own, it is essentially the CPU, the central processing unit of the human system. So there are 86 billion neurons, and they're connected to millions of synapses. So you can assume that is the kind of network which exists in just about 1.5 kgs worth of mass. And that's phenomenal and something which is still being worked on for ages together to still be understood properly. And the human brain forms one of the major inspirations for artificial intelligence and how we're building new networks based on our neurons, and they are called neural networks. And there are different forms and types. I'm not going to touch upon the details of it today, but we should know that a lot of the learning, which part of the artificial intelligence, is based on the human brain. Now let's get to artificial intelligence. And anybody whom we ask is um, mostly has this view because we are mostly experienced or exposed to movies which kind of show us these sci-fi concepts. And I was in the same boat quite a few years back. But what's the first thing which comes to mind when we say artificial intelligence to the to a layman who is not exposed to these concepts? It is robots mainly which come into mind, which are automating something and maybe even heading towards world destruction or anything like that. Obviously, all those are manifestations of human intelligence, or rather the imagination of human intelligence for artificial intelligence. So let's keep it aside for now. While they're fascinating the way they have thought of these concepts, it's still a long far away aspect of AI. So what exactly is AI? Um, Artificial intelligence is a field essentially of studies which combines the science of computers and with along with various kinds of data, right? Like I mentioned, the way our intelligence works is also based on data. So we have data from our ears, our nose, our eyes, our thoughts, our our culture, um, uh, and even our experiences, or even the environment in which we grow. Similarly, any artificial intelligence system is exposed to a certain kind of data set, and it is trying to solve a certain problem. That's the basis of building an artificial intelligence system. And so you have to note those key terms, that essentially it's directed towards solving a certain problem. It's working on data sets, and you might have heard this popular phrase, garbage in, garbage out. So depending on the kind of data which is given to the system, you get the appropriate output. So it really, the data is very, very important when it comes to artificial intelligence. And then we're going to use various concepts of computer science to reach a certain solution or a prediction based on what we are trying to do. Now, there are subfields in artificial intelligence. Many of you may have heard these terms interchangeably, but it is important to note that artificial intelligence is the overarching field. And machine learning will be a subfield of artificial intelligence, and then deep learning will be a further subfield of machine learning. So machine learning is essentially um, algorithms which are trying to create specific um, you know uh, systems or specific functions to come up with an answer. And deep learning is trying to work with data which you're not aware of, which is not classified, which you have to analyze, mostly trying to function like the brain which tries to understand something new. Deep learning is all about trying to understand something which is completely new by trying to categorize in various ways. So it's important to note that deep learning is a subset of machine learning, and machine learning is a subset of artificial intelligence. We will see this being talked of in the further slides as well. But whenever you come across this, to know that there is a hierarchy of structure here. Okay. Let's now briefly touch upon some history of artificial intelligence. I'll just quickly pause here. I am getting some questions on the chat. Do you want me to address those questions as I get them, or should I just take it all at the end? Is that
Maybe at the end, please. Thank you.
okay? Thank you. All right, so let's just talk through some of the history here. And what's key to note is that the history of artificial intelligence dates back more than 75 plus years, right? So it started in 1943 when there was a conceptualization of artificial neurons to see if we can mimic the neurons in the human brain to do some functions. And I'm not sure how many of you are aware of it, but Turing machine, where they were trying to classify machine's response versus a human response, was one of the first ones where this was implemented. And then the term AI, or artificial intelligence, was um, uh, coined by the in the Dartmouth conference there in 1956, and that's one of the significant milestones in the history of artificial intelligence. And then we had the first chat bot. This particular snapshot of image has a lot of typos, so kindly ignore it. I forgot to mention this early, but I did want to state courtesy for the slides. It's from various sources on the internet, and assimilated from various different sources. So yeah, so chatbots are something which we are fairly familiar with now, but it was a major development in 1966, if you think about it, where something was automated to respond to a human. Today, it's very common for us. We pick up Swiggy, or we pick up any other service app. There is always a chatbot, or even your Airtel or whatever is providing your service. There's a chatbot which tries to respond to your question appropriately by analyzing what the text is, and what the appropriate response would be based on your location, or maybe even your previous history. But this we're talking about in 2021. But in 1966, that was a huge thing to come out with, ELIZA, and that was very crucial for AI development. And then there was a Wabot intelligence a robot which was designed for a certain specific task. Um, but what happened after this time frame is essentially that a lot of these sci-fi fictions came in. People started analyzing that this may lead to some. There was a lot of conspiracy theories, and you to note that artificial intelligence is extremely dependent on the machine. Like I said, it is a combination of computer science with data sets. While data always existed to a certain extent, the ability of the machines in that period of time was significantly low. And to quote an example, today, if we think of 1 GB of data, it's nothing. It's probably just as small as one small memory device. But at that period of time, even 1 MB was equivalent to one particular drawer or one huge chunk of memory disks. So there's a lot of dependence on the advancement of computer hardware and even computer software for the sake of development of AI. And therefore, between 1974 and maybe even until 1993, so to say, there was something called an AI winter, where there was no work explored in the AI front. There were some expert systems built in 1980, but they didn't really go anywhere. But this was a crucial period as well, because we lost a lot of those years with no developmental work or even funding provided by governments or companies for the sake of development of AI. Now, the first major development which kind of excited the world was the development of the IBM Deep Blue supercomputer. It beat the chess champion of that time, Kasparov. A computer beating a human was unheard of, and obviously developed a lot of interest because of the sheer capabilities or the prospects which existed for such systems. And from there on, it was a steady, set of developments in the AI region. We are all aware of automations for home. The Roomba came up with their first automatic vacuum machine, which was able to identify obstacles, identify stairs, and work accordingly to vacuum a home. And that was significant in 2002. That's about 20 years back. And then in 2011, IBM built the Watson system, which won a quiz show, which is called Jeopardy, and that is not a straightforward quiz show. The question, the answers have to be in the form of a question, so that the system has to analyze all the clues which are given to it, and then come up with the answer in the format of a question, and also have the answer in that question. So it was a major development in the area of AI, and Watson is still famous. Watson is used a lot in the medical field as well now. So then, since 2011, there's been a lot of development, and a lot of these are probably something which we are used to now, and we don't really think or sit back to think how these operate. Like, for example, we all have heard of Siri or Alexa or Google now, or Google Assistant. Um, so all of these are very intelligent AI systems underneath, where they are taking in the input which you give, either in the form of voice or in the form of text, and they're giving you appropriate answers. Key thing to note is they're essentially just assisting you. They're not trying to take decisions for you. So this is where AI is at this point, and it's obviously much further along. But we've also got the Amazon Echo, and which can now the major development from earlier to now is that there is also the added input of different accents of language. So it's called natural language processing, or NLP, and that is heavy now, because a product like Amazon Echo should work irrespective of whether a person is from India or from China or from Yugoslavia or from US. or UK. So all those accents have to be identified. There have to be filters in place to make sure that you get the right, representation, interpretation of those words, and then come up with the right response as well. And the response also has to be based on geography, location, previous experiences, and many other factors. So, while it may seem like a small device which is just doing what you want, there's a lot of science built behind it. And that's something which we should probably think about next time we interact with a device of that form. So this is the brief history of artificial intelligence, and this is just the tip of the iceberg, so to say. There are so many things in development at this point, and an exciting future ahead. But it's important to know how this developed, and even though it was conceptualized 80 years back, um, it took so much time to come up to this point, because there is so much dependence on the computer hardware, computer software, and funding and other aspects of things. So that's a brief history. Forward. So now let's talk of the various types of artificial intelligence which exists today. So there's something called weak AI or narrow AI, and then there's something called strong AI, or the strong AI has multiple categories. So in weak AI or narrow intelligence, essentially it is looking at a certain goal. It's trying to achieve a certain goal which you have predefined or you are going to expect, and then it will do that as a task. So for example, you have your voice assistants, or your self-driving cars, spam filters, and many other examples which you may see, or even your photo apps in your phone which tries to find your face, is a part of weak AI, because it's got a singular task. So those, you may if you think about the um, algorithms which may have gone beneath that, that itself must be at such a complex level. To take an example of Alexa, let's say, it has to process your voice, it has to identify what you're asking, it has to find the right source, it has to curate it to make sure that it removes any false positive matches, and then come up with the right answer. That itself is quite a complex task. And if you think about it, that falls in the category of weak AI or narrow AI at this point. So strong AI is what we refer to as machine intelligence or machine consciousness. So essentially, going from left to right, it's more autonomy for the machine, in the sense that a machine should be able to do a task without human interference as much. That is the main intent here. It may look like, okay, they're getting more intelligent than us, but that is for a purpose, because we are trying to achieve a certain task with it. Now, artificial general intelligence and artificial super intelligence are only hypothetical at this point, because we've not been able to even mimic our own brain yet. So artificial general intelligence is essentially where it is all equivalent to the intelligence of a human, and then artificial super intelligence is where an intellect will be much smarter than a human, in almost every field. And it will obviously take a lot of time to get to this point. And you can think of autonomous machines, or autonomous production, or autonomous, so many things, which are possible in this area. And it obviously requires a lot of training data, which we call, where it is collecting. That's why you'll see that there's a lot of discussion about data collection, and there's a lot of debate about data collection and how much of it is acceptable, how much of it falls in the personal area, how much of it falls in ethical area, and what is okay for a machine to collect. So it needs a lot of this data from a lot of different data points, which would be humans, which would be machines, which would be environmental factors, which may be games, which may be so many other things, for it to come up with a system which is able to mimic a human thinking. Now, let's just pause and think about how we would think of a problem. And we would think of all our experiences. We would think about everything that we've seen before, which is relevant to that topic, or we have read about it, or we have heard about it from someone, or we have used our imagination for something for that matter. So you know artificial intelligence at this point is mostly learning what we give it, and not at the capability of coming up with its own thoughts related to those aspects. So that's why we are still in it's still in hypothetical region. The general and super intelligence is strong AI systems. But there is certainly exciting work going on. There is something called deep learning, which is a UK-based system. They have been acquired by Google now, and they have come very close to um, mimicking some of the actions of the human brain. There was some of it discussed in some of the conferences, and it was very exciting to see how they do it. You may also have seen examples of fake images or fake videos, and that is also an example of an AI system where it can mimic the exact facial contours, the exact pronunciation, the exact movement of lips, and exact change in tones for a particular person. Those are called deep fake videos, and they're all highly trained artificial intelligence machines. So those are just examples, but yeah. So just wanted to state that for people to uh, appreciate. Okay, how am I doing on time? 4:40. Okay.
You have another 20 minutes, sir. No issues.
Okay, sir.
25 minutes.
Thank you. All right. So now let's get to some deeper aspects as to what goes into these systems, and what are the different classifications and examples. So now we talked about machine learning, which is the basis for some of these AI systems, that it needs to learn from everything that it is exposed to. So now there are various forms of learning. I just put that table on the right for reference purposes. Don't necessarily have to go into the detail of that yet, but I'll just talk through the higher levels here. So there are various forms of learning. There is supervised learning, unsupervised learning, reinforcement learning, and semi-supervised learning. So what is supervised learning? So essentially, anything which you get as data, if it is labeled, like for example, let's say your image processor in your phone is going through some of your photos, and each of them have, let's say it is a collection of cats and dogs. Let's say that each of them have been labeled already, that this is a cat, this is a dog, this is a cat, this is a dog, whatever, right? So then the system already gets a labeled set of data. So then it can start classifying based on that labeled data. So essentially, you're making it simpler for that system to come up with a certain answer, let's say. Now, inside that, you've already, let's say, you've named it cat and dog, but inside that, you're trying to find a brown dog or a black dog or whatever, that the system can do, because it doesn't need to do the initial set of classification or identification of what is a dog or what is not. So you can take that as a simple example of what supervised learning will be. Now, unsupervised learning is where the data is not labeled; it is essentially raw. Um, so we will then have to use deep learning algorithms, or essentially try to mimic how our brain would try to process it to come up with classifications. So that's what is called unsupervised learning, and this I've marked in red because this is the most crucial area for artificial intelligence, because all the real data in the human world will be unsupervised. So you're speaking of something, you're speaking in a certain tone, you're giving it a bunch of photos which may not have classifications. It may, all that will be unlabeled data, right? So it doesn't know what it is. It will have to find a way to identify each of them and classify them in certain buckets, and then reclassify them based on what the intended identification or purpose is. So unsupervised learning is the most fascinating area as well. So some examples would be, for example, a company is trying to identify classes of customers, right? Let's say Amazon is identifying all its users for the kind of purchase histories that they have, the kind of things they're purchasing, how frequently they're purchasing that, and then what is the kind of products that they're purchasing. So then so then it will try to segment the customers based on their preferences, and then try to um, bucket them in a certain category so that it can give the right recommendations inside the app. So that you would have already seen that in Amazon, when you clicked on a product, it will tell you customers who bought this item or have looked at this item have also looked at so and so item. So that is just a very simple example. Then there's also something like a sentiment analysis, which could be either language processing or text processing. So it may be looking at a text and analyzing what is the kind of sentiment you've written the text with. Now, I can speak to some personal examples in our company. So there are feedback cycles where we are giving feedback to people, or we are getting feedback from people towards the end of the year, where we're trying to understand how we are perceived by others. So when this feedback is being written in that system, and we write down the feedback, let's say I write down a feedback for one of my teammates, then it will give me an immediate feedback based on what I wrote, that based on how you wrote this kind of sentiment is coming across. It's probably looking a bit negative. It's probably looking a bit uh, only positive, or it's looking fairly well constructed. It looks like you're giving constructive criticism. So it analyzes all those text lines to understand the kind of sentiment you're trying to convey in your message. Now that is just text. Voice is even harder, because voice is not always modulated similarly across different people. The same message may be conveyed in a very calm way by one person, and a very inflated manner by another person. So now the system has to be capable of identifying the words which have been used, and come up with a classification on what that sentiment that person has. So this goes down to the very minute details, and it's very crucial for us to understand this. Anything which is not labeled becomes very hard to classify, and you will see that there are actually many different ways of doing it, many different neural networks which are used, which can be used for this. So that's unsupervised learning. Then there is reinforcement learning. So this is pretty much how our parents have trained us, right? If we did something good, they would praise us. If we did not do something good, they would admonish us. And it is a trial and error method. And the trial and error doesn't necessarily only have to be by personal experience. It could also be from other experiences. Like, for example, they teach you when you're in school, let's say another kid is misbehaving, they show you their example and tell you, see, if you do this, this is what will happen. And it's essentially reinforcements. It's essentially positive or negative reinforcements to come up with the right solution. And you can think about this in the example of games, where if you approach the game in a certain way, then then it is going to do this or do that. And then similarly with robotics, if the robot is trained to do a certain task like a human, how is the kind of the reinforcement system for every step it takes for it to reach the right solution is what forms reinforcement learning. Then we have the semi-supervised learning, which is essentially a combination of both supervised and unsupervised learnings. So essentially, it will have a mixed data set where a part of that has been labeled by some experts in that field, or some other persons who are analyzing it, who may be data scientists. So they may be looking at how to put this together. So then, based on what they have labeled, the computer system will then try to apply that knowledge to the remaining set of data points to understand how to classify them. So this is called pseudo labeling, where based on some golden set of inputs, it tries to understand how that has been labeled, and that itself is going to be a network of analysis. And based on that, it will try to apply that on the remaining sets of data to come up with something which is accurate. And an example for this is MRIs. For example, let's say there is a radiologist who's sitting in and putting in a few things, labeling them in a certain manner, and then he just feeds that, and then the system uses that. Let's say he does 50 of them, and then the system uses that to do 500 more, based on what the observations are from what the expert did. So obviously there are corner cases here. There may be cases which are missed. How do you label them and other things? But you're not getting into those details here. Good to know that this is also a form of learning which exists. So these are some of the learning mechanisms which exist. Okay. We spoke of the learning mechanisms, the history, the types of artificial intelligence, and some of the possible applications which we have already or are going to come up. Now, there are a bunch of challenges with artificial intelligence. You may have heard already about a few of them. Like, for example, one of the most famous ones is an ethical bias or ethical AI. How would a self-driving car decide to go if it sees an animal and a human, which are the only two options for it to collide with? So that there's an ethical aspect to it. Then there are so many other things which have been touched upon in movies as well. How much of these automations, especially when we talk about the artificial general intelligence and the artificial super intelligence, how much of those rights should we give the machines? What is the bound for those machines? How do we set the cap? And then how do we make sure that some of these highly capable um, AI systems are not used for the wrong reasons, for example, arms. And then how do we make sure that there is no bias, any kind of bias? It may be religious bias, it may be gender bias, it may be racial bias. How do we make sure that an AI system is not doing something like that? An example for that is, now let's say any AI system is guided by a human expert. Now let's say there was some image classification which was being done by a human expert, and that human was a uh, white male or a set of white population, and then inherently they may put in whatever their um, unsaid biases into the system, that train it this way, train it this way, and they may not require, no, they may not realize it actually. All of us have this unconscious bias for many things. We may like something, we may not like something. It doesn't necessarily have to be discriminatory. It is just a preference of our own, and we should make sure that any kind of artificial intelligence system that we build is not based on any such bias, because the system is expected to be rational. It's not expected to mimic a human behavior, because each human is different and the system applies to all. So bias is a very crucial aspect when it comes to AI, and how we're going to do it. Um, then there's also stupidity. Again, a lot of it has to do with the data which comes in, and the filtering and the classification. We spoke of some of the learning mechanisms and how it classifies things. And there's a significant possibility of some stupidity. And there have been real world examples as well, where an AI system identified a cat as a bag as a cat, or vice versa, because they were both those printed skins or patterned skins. So it takes time to build in more accuracy. So artificial stupidity is certainly one thing which we have to be mindful of before using for general purposes. Security is another major aspect, especially when we start building artificial autonomous systems. Like, for example, let's say you build an autonomous system for handling all your banking applications. How do you sure that it is because a large part of machine learning and even AI is in a way a black box, where the end user will not really know what is going on inside. It is essentially giving you an answer, whether it's assisting you or giving you the final answer. That's separate based on the type of system, but it is essentially giving you an answer. So you really don't know what's happening inside. So it's very hard to make out upfront whether there have been any malicious attempts underneath. So security is certainly a major aspect as well when it comes to AI. We spoke of many of these things, and one of the major concerns across the world and many industries is the loss of employment. What happens if everything is automated? Now, this is it's valid to an extent, but no, we are also discounting the fact that these AI systems will generate their own employment as well. That, there will be requirement for machine learning experts. There will be requirement for coders who write up these systems. There will be requirement for data scientists who will analyze the data and look through the data, sift through the data. So there's a lot of employment coming our way when it comes to AI. Though there is not a conclusive study on whether it will be on an equal proportion. Certainly, there's a huge scope, and like I mentioned, this scope exists across fields. That no matter what field we take up, we will find it. For example, let's take agriculture for that matter. If we take agriculture, a system is analyzing a certain geographical field. It has to make sure that it accounts for everything associated with that geography, associated with that section of people and the kind of crops they grow and other things as well. So many things to consider, but these are some of the current challenges as the industry drives the policy associated with these AI systems. Going forward. All right, so we spoke a lot about artificial intelligence and its types and applications. Let's briefly speak of augmented intelligence. Augmented intelligence is essentially a subset of AI where it is trying to aid your intelligence or your functionality. So it is just trying to, it is not going to take any kind of decisions. It is only going to stick to what you ask and analyze data from sources which are not of immediate access to you and give you an answer. And there are many examples of it. There are virtual assistants like Alexa, or even the MG Aster came up with a virtual assistant in the car where you can ask it something and it will do it just based on your voice input. Or even it may even I think it has a function for even telling you a joke as well. So again, all of these are specific purposes. So you tell it to do something, it will find out from n number of sources and tell you. Like for example, you may ask Alexa, play the most famous Muhammad Rafi track from 1970s or whatever, right? So and then it will look through all of its data and come up with that answer and give you that answer. So that's an example. And then more common things which we're almost way too used to right now, but we don't, we probably don't think back or appreciate is some of these streaming service recommendations. So based on what you watched, it will go and find out similar content. So you have to understand that it has to understand the content of that movie or the content of that TV series, and then match them with what you have watched, and then come up with the recommendations. So that's also an example of augmented intelligence where it is trying to aid aid you by giving you similar suggestions or something like that. And then another popular example with the kids is, or even adults, I should say, is video games, right? And video games is a huge industry, and our parents may scoff at it and say, "Oh, what is that? It's a video game," but it is a multi-billion-dollar industry, and a lot of science goes into making these as well. So for all of you who have played a video game, you will obviously be exposed to environments which are artificially created, virtual reality, where it's creating a certain environment while you're playing that game. And that environment may be based on how you played the game before and what is the kind of things your teammate is doing and whatnot, right? So all those environments have to be generated on the fly based on your previous experience. So it's augmenting your experience with its understanding from various different other sources. So all these are just examples of augmented intelligence. Usually people sometimes use it interchangeably, but it is not exactly the same. So just a point to note. So augmented is anything which is trying to aid your own intelligence with various sources, and artificial may end up being an autonomous system where it takes the decision. So that's about augmented intelligence. I think I have just 4 minutes left. Just speak briefly about future prospects. Like I mentioned, there are a lot of prospects for AI, and some of these we cannot even imagine. Like for example, there has been an AI system to find out a different uh, galaxy where it was where they found an 8-planet galaxy in the universe by just using AI for studying the various planetary positions and their behaviors and how they're working and whatnot. And then there are, like I said, there's a lot of prediction-based analysis where it's trying to predict what you may do, what you may buy, no, it's not just at an individual level. It may also be at a regional level or even a country level or even whatnot, right? So, for example, there is a lot of predictive analytics which goes into elections, which goes into moods and sentiments of the crowd, which goes into predictive analysis based on weather patterns, what kind of weather can be expected for a certain region, and then it will tell you this may be a good thing to pursue or whatnot. And like I mentioned, there's a lot of language processing, language translation, text to speech, speech to text, image recognition. Image recognition is huge. Let me take a recent example now. Until recently, for all those of you who have some aged parents, it was mandatory for the elders to go to a bank and identify that they are still around for them to get their PF. And now that system has changed to just an AI-based system where you can sit at home, show your face to your mobile, and validate that you are still around and you need to keep getting your PF. So those are real ground level applications which have already been implemented. There are a lot more of these which are coming in, where any kind of recognition, analysis, and machine vision can be used to make lives a lot more easier. And like I said, it can be applied in all kinds of uh, fields. Now most of you are based out of PU, and you have either gone through some PCMB, PCMC, or PCME kind of backgrounds, and there is analysis going on to find different compounds in the chemistry side where you can where it will try to analyze what kind of compounds put together would give us a certain material. There may be exciting prospects like super efficient batteries, which is still not found. If you think about it, our electrical vehicles right now are all fairly low efficiency for the kind of area that they occupy. And if you think about it, a system like this can go and analyze a bunch of things and come up with a different structure to probably create a high capacity battery in a small form factor. Similarly, in physics, for all there are a lot of applications to find out associated with quantum physics, and how we can do exponential kind of applications with quantum physics. And in biology, there's a lot going on in finding out, like for example, prediction of Alzheimer's. Understanding there are devices which have been created which you can just patch onto your body, and it will analyze everything associated with your movement and let you know whether you have some small changes in your neural patterns or in your movements, which can probably be an indication of you know, a health issue. So there are a lot of things coming up, and then there's um, brilliant new aspects coming in. Like I said, I mentioned about deep learning, where it is trying to predict what may be a certain compound to use for a certain uh, for a certain um, for a certain material, like let's say very intelligent humanware, or humanware which can by itself detect some things physically, especially for older people and other things. So there's a lot of aspects. I just stated the areas here. So there's a lot of good career prospects here in AI. And so I would highly encourage all of you to think about it in those lines. Even if you don't pick purely AI as your future prospect, you can certainly think about the associated areas. There are, like I said, data scientists. There are computer algorithm writers who come up with all the brains behind these functionalities. Then there are hardware which needs to be built for this, which is if somebody is pursuing electronics, you can think about what kind of hardware would be required for these. There are it's already in progress where there are hardware built specifically for AI, where you may require higher levels of memory encryption, whatnot. So those are some of the things which are in the horizon and things to think of. So that was my last slide. I think I'm 2 minutes off time, but any questions? Yeah, I had a bunch of questions.
Yes, thank you very much. There are few questions, but most of the questions you have covered in your sessions are already. What is the difference between neural network and deep learning?
Deep learning essentially uses a neural network. So neural network is the mechanism by which we do deep learning, where it is trying to take in some inputs. It's got a set of input layers, certain set of hidden layers, and it is trying to form something like our brain's neural network to go and try and categorize the data and come up with an answer for the input data which we get. So neural network is what is the backbone of deep learning. That's the right way to put it.
Thank you very much. And what is the difference between machine learning and data science?
So, like I said, data science is all about analyzing the data. So the data is the most important part of this. So if we go back to what artificial intelligence was, it's essentially combining computer science with data. And and the proper categorization, it's not just about categorization of data. It's also about removing false data. It's also about making sure that the machine or the system gets the right input. Now, for example, let's say it's analyzing some speech patterns for some person. In the background, there's a dog barking or another person putting in another word or whatnot. It has to make sure that it is not considering those as part of the input which is being analyzed, because it will then obscure the results which come out of that system. So data science has got a lot to do with analyzing, categorizing, and giving in the right data to an AI system for it to do the job properly. Machine learning is the overall and all-encompassing learning part of it, where it is trying to come up with those algorithms to make sure that we're taking the right decision.
Thank you very much. And sir, is artificial intelligence a part of computer science and engineering considered these days?
So yes, so one of the major things used in artificial intelligence is Python programming. The framework, and Python is certainly part of one of the programming languages which covers in computer science. But I was recently exposed to the fact that now artificial intelligence is being offered as an engineering course by itself in colleges. So while it is part of some of the things which are studied as part of standard curriculum for electronics or computer science engineering, it is also a specific branch being offered right now. I have not had the chance to look at the syllabus to see how they're covering and what they're covering. But all I can say is it is certainly the future, and everything will involve AI, so worth exploring that as well. So I did get a question where somebody asked me, "Sir, I've decided my career in AI. Can you tell me what should I concentrate on?" So you want to pursue a career in AI, it's also about what part of it excites you. Like I said, AI has many components. There's the data science part of it. There is the algorithmic writing part of it. There is the building the software and hardware for AI processing part of it, and many things which are associated with it. So if you want to build your career in AI, you might also want to think about what part of it excites you and what you can relate to more based on what you've studied today or part of your current coursework. So, one of the things you can do is do up some of these courses. I don't know if you've already been selected a college for your engineering, but if you have, that's still not hindering you. You can always pursue some courses offline, where there are specific targeted AI courses for deep learning. I would suggest that you go into deep learning, because that's where more of the exciting prospects exist. since you are post PU right now, it's going to be another 4 to 5 years before you come out into the industry. And by that time, I see that the scope for deep learning and unsupervised learning will be a much higher prospect compared to other things. But like I said, we're just at the tip of the iceberg. There's a lot of opportunities. But that's my suggestion at this point, that you should think of um, areas which it's also one thing to think of is what you want to do. Like for example, you don't necessarily have to get into a tech conglomerate to contribute to AI. You could even get into agriculture and think about what the end goal is. Like for example, let's say you coming up with a solution for crop burning, stubble burning or whatnot. There is already something which is being proposed, but I'm just taking an example, right? And for that also you probably can use AI, and so it's also about how you want to use it. So you could marry an area of interest and AI to come up with the right way to proceed for yourself. So it could be agriculture, it could be chemist, let's say you're very interested in organic chemistry and you want to find out new compounds or whatnot, and you want to pursue a career there, you can still do it and do the AI part of it, because AI is going to be like your intelligence. It will just be machine assisted intelligence to make you faster. So think about it in this way. You may have seen the Matrix movies where you plug in a chip and you know something immediately. So it's almost like that, right? Where you're going to give some input to an AI system and it's going to come up with some of those answers a lot faster than what a human could do with a few months of research. So I would say you can think about it in many ways, but should be something which you are previously interested in with as well. If you don't have a particular area of interest, I would say you should think more about deep learning and aspects related to that.
Thank you very
Okay.
much, sir. Yeah.
You're welcome. I think the rest of them, most of them have covered in what.
Yeah. You have covered all the questions in your topic
Okay.
itself, seminar itself. Thank you very much, sir.
Thank you very much.
One more thing, that is a debatable question, which is based on the future. There will be more unemployment due to artificial intelligence. So on that, what is your opinion, sir?
Yeah, so I think I mentioned this as well, that yes, so artificial intelligence is built for automating repeatable tasks for sure. And because we're not only increasing efficiency, it's also based on historical data. So so certainly some of those repeatable tasks may not be something which will stay for too long. Again, it's not something which we should take as a fear. It should be something we take as an opportunity, because we have to get out of that mindset and start exploring newer things, start exploring the problems which are affecting the world, and how we can use this additional tool which we have, or additional help which we have, to come up with better solutions for making the overall human life better, right? And I think I mentioned this earlier as well, that while some of those repeatable task kind of jobs may get affected in the not the near future, but at least in the next 10 years, uh, we should think about how many jobs are getting created because of this as well. There are hundreds of data scientists required. There are hundreds of coding experts required. There are hundreds of you know ideation required for guiding these systems to the right solution. So the cartoon on the right here kind of tells us a bit as well, that if you're going to expect that you're going to create a system and just flip a switch and it will give you the right answer, the machine itself will probably tell you you're not doing the right thing. So you need to give it the right inputs, and for you to give it the right inputs, you need a certain level of expertise. And that's where I think a lot of job opportunities will come in, where there'll be subject matter experts required for every small aspect of input which is given to a system. And all those job opportunities will come up in the future. Already they are there. They will only increase in the near future. Like I said, I don't know whether it will be 1:1, and that is debatable, right? Depending on how many. So let's say, let me put it this way. Now let's say this conference is being attended by 10 people from post PU. and each of those people come up with 5 different great ideas to implement. Each of those 5 different ideas will require probably 50 people each to implement. So there itself, you got 250, jobs created. We should think about it in that way. That we should all think of what different things we can think of with this, additional capability, and how to create more value out of it. Okay. Yeah, and a personal concern of mine is that we are all the middle cartoon kind of. While all these systems are great, we should make sure that we are getting sharper as well, and that's why I talked about subject matter experts, or people who have a lot more experience in certain field, and all those things are very important. We should, the major tendency right now is to sit back and tell Alexa to do something. And right now it's just doing commands. It will then extend to cleaning the house, folding your clothes, or whatnot, right? It should not end up being a decrease in our real intelligence when increasing artificial intelligence. So we have our part to play too.
Adarsh,
yeah,
thank you very much for a very informative, insightful, scintillating talk on artificial intelligence. Congratulations to you. And you covered most of the basics of artificial intelligence. I'm sure students present here will be highly benefited by the talk. And some of them will certainly pursue a career in artificial intelligence and data science in the coming years.
Sure.
It was a very, very useful session. On behalf of KSTA and all the participants, very grateful to you very much. We keep organizing workshops like this. We're inviting you again for some more talks like this. Grateful to you. Thank you very much.
Thank you very much. Thank you. Bye.
Participants, ನಾಳೆ ಪ್ರೊಫೆಸರ್ MRN ಮೂರ್ತಿ, ಫಾರ್ಮರ್ ಡೀನ್, ಇಂಡಿಯನ್ ಇನ್ಸ್ಟಿಟ್ಯೂಟ್ ಆಫ್ ಸೈನ್ಸ್ ಅವರು ಫಾರ್ಮ್ಸ್ ಅಂಡ್ ಫಂಕ್ಷನ್ಸ್ ಇನ್ ಬಯಾಲಜಿ ಅನ್ನೋ ವಿಷಯದ ಮೇಲೆ ಟಾಕ್ ಕೊಡ್ತಾರೆ. ತಾವೆಲ್ಲರೂ 4 ಗಂಟೆಗೆ ಮತ್ತೆ ಅಸೆಂಬಲ್ ಆಗಬೇಕು ಅಂತ ಕೇಳ್ಕೊಳ್ತೀನಿ. ಹಾಗೆ ನಿಮ್ ಜೊತೆಗೆ ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸು, ಕ್ಲಾಸ್ಮೇಟ್ಸು ಯಾರಿಗಾದ್ರೂ ಇಂಟ್ರೆಸ್ಟ್ ಇದ್ರೆ ಅವ್ರನ್ನು ಸಹ ಜಾಯ್ನ್ ಆಗಿ ತಿಳಿಸಿ. ಸರ್ ಮೂರ್ತಿ ಅವರು ಬಹಳ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ಡ್ ಟೀಚರ್. ಅವರು ಕರ್ನಾಟಕದ ಹಲವು ಭಾಗಗಳಲ್ಲಿ ಈಗಾಗಲೇ ಟಾಕ್ಸ್ ಕೊಟ್ಟು ಪ್ರಸಿದ್ಧಿಯಾಗಿದ್ದಾರೆ. ನಾವೆಲ್ಲ ಮತ್ತೆ ಜಾಯ್ನ್ ಆಗಬೇಕು ಅಂತ ಸಂದರ್ಭದಲ್ಲಿ ಕೊಡ್ತೀನಿ. ಧನ್ಯವಾದ.